and welcome to Pre-Algebra Test Section 1 on adding and subtracting fractions. So for the problems we're going to look at today, we just want to find the LCD. Again, this means the least common denominator of the fractions. So we're going to start out with these two fractions here, 1/8 and 1/12. So I know a lot of you get confused when you start talking about LCD, LCM, GCF, GCD. Again, as you practice with these terms more and more, you'll not only understand what they are, but where and when to use them. So the LCD is found by finding the least common multiple, again abbreviated LCM, for the two denominators. So the least common multiple of 8 and 12 is what we're looking for here. So how do we find the least common multiple? Well, we'd factor each number. 8 is 4 times 2, 4 is 2 times 2, so we'd put 2 times 2 times 2. For 12, we'd put 4 times 3, or 2 times 2 times 3. Now, when you build your LCM, essentially what you're doing is you're looking for factors that are common to the prime factorizations of all the numbers. In this case, you can see that 2 is common to both. Now, when that occurs, you put the largest number of repeats from any of the prime factorizations. So in the prime factorization of 8, you can see you have 1, 2, 3 factors of 2. In the prime factorization of 12, you have 1, 2. So the largest number of repeats occurs here. So when I build my LCM, I'm putting 1, 2, 3 factors of 2 in there, because again, that's the largest number of repeats from any of the prime factorizations. Then the only other number we have is a 3. That's not common to both, so we just throw it in there. All right, so now we just multiply, and we'll have our least common multiple, and therefore have our least common denominator. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So the LCD here, the least common denominator for these two fractions, 1/8 and 1/12, is going to be equal to 24. Let's take a look at another one. Let's say we had 2/3 and 5/18. So again, the LCD, or the least common denominator, is going to be the least common multiple of the two denominators. So 3 and then 18. But again, let's go through the process. So 3 doesn't factor, and 18 is basically 3 times 6, or 3 times 3 times 2. And so when you build your LCM, it's basically going to be 2 copies of 3 and 1 factor of 2, or just the number 18. So the LCD here is going to be 18. Okay, let's take a look at one final problem. So we have 2 over 14, 3 over 50, and 5 over 64. So again, to find the LCD, we're trying to find the LCM, the least common multiple, of 14, 50, and 64. So we're going to factor each number. 14 is easy, it's 2 times 7. 50 is easy, it's 25 times 2. So I'm going to put 2 times 5 times 5. And then 64 is 6 factors of 2. So 2 times 2 times 2 times 2 times 2 times 2. Right? You just think about it as 8 times 8, right? Or 6 factors of 2. So when I build my LCM, the first factor, or the smallest prime factor in any of the prime factorizations, is 2. So 2 is common to everything. So again, I go with the largest number of repeats, and obviously that occurs here. So I'm going to put 6 factors of 2 in here, and I'm going to go ahead and just write that as 64. Just to save on space. Then the next thing I notice is I have 2 factors of 5. That's not common to anything else, so that just goes in there. And I have a factor of 7. That's not common to anything else, so that goes in there. So basically we have 64 times 25 times 25 times 7. So in the interest of time, I'm just going to do this multiplication with a calculator. 64 times 25 is 1,600. Then if we multiply by 7, we would get 11,200. So that's going to be your LCD. So your least common denominator is going to be equal to 11,200. Hello and welcome to Pre-Algebra Test Section 2 on adding and subtracting fractions. All right, so for the problems, we're just going to perform the indicated operation. We're really just going to be doing some addition and subtraction. So we're going to start out with 4/25 plus 6/25. So very important when you add or subtract fractions that you have a common denominator. In this case, we do have a common denominator to start, so it's a very simple problem. If you already have a common denominator, then your answer will have that common denominator. So in other words, I just take that 25 that's common to both and use it as the denominator for my answer. Don't make the mistake of adding 25 plus 25 and saying that, okay, this is going to be a denominator of 50. Right? The denominator is not going to change. The denominator will stay as a 25. Now I'm just going to add the numerators. So 4 plus 6 is 10, so I get 10 over 25. But we're not done. Whenever we work with fractions, we want to report our answer in simplified form, or as we'd say, reduced to its lowest terms. Now, at this point, you might be starting to get pretty good at this, and you might be able to eyeball that and say, okay, well, 10 is 5 times 2, and 25 is 5 times 5. So the greatest common divisor between the two, or the greatest common factor, it's the same thing, would be 5. So I can just divide each by 5. So divide 10 by 5, and I would get 2. Divide 25 by 5, and I would get 5. And I would have my simplified form for this fraction of 2/5. All right, let's take a look at 8/11 plus -4/11. And again, we have a scenario where we have a common denominator. So that stays unchanged. We just write the denominator as 11, and we just perform the operation with the numerators. So I'd have an 8 plus a -4. That's the same as 8 minus 4, so that's 4. So if we have 4 over 11, that's already simplified, right? 4 is 2 times 2. 11 is a prime number. So 4 over 11, or 4/11, is our answer. Okay, now we look at 6/7 minus 5/7. And again, we have a common denominator. So we're going to write that as the denominator in our answer. And then we just perform the operation with our numerators. So we do 6 minus 5, and that's 1. So we get 1/7 as our answer. So 1 can't be factored. It's not a prime number because it's excluded from that definition, but we can't really factor it. We can't do anything with it. 7 is a prime number, so we can't factor that either. We could do 7 times 1 if we want, but we really can't do anything. So 1/7 is as simple as we can make this fraction, so that's going to be our answer. Okay, for the last problem, we have 7/12 minus 4/12. And again, we have another easy one where we have a common denominator already. So that's going to be the denominator for our answer. And then we just do 7 minus 4, and that's 3. Now, eyeballing this, I know that 12 is divisible by 3, right? Meaning 3 is a factor of 12, or 3 is a divisor of 12, however you want to think about that. So if I know that right away, I can divide each by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So again, that gives me a simplified fraction of 1/4. Again, that's kind of the quick way to do it. The slower way would be to say, okay, I have a 3 up here. 12 is 4 times 3. 4 is 2 times 2. And then just look between numerator and denominator and cancel here. Again, this is fine if you want to keep doing this. And a lot of times when you first start, it's probably better to do this so that you don't miss any common factors. But once you get good at it, you're going to speed up and do it this way, because on a lot of tests, you'll be timed and you won't have extra time to go through and do this. Hello and welcome to Pre-Algebra Test Section 3 on adding and subtracting fractions. So we just want to perform the indicated operation. And again, we're just going to be adding and subtracting some fractions. So we're going to start out with 3/7 plus 1/7 plus 2/7. So again, if you've watched all the videos up to this point, you know that when you add or subtract fractions, you have to have a common denominator. In this case, we already have one, and that's a denominator of 7. So for our answer, we have a denominator of 7. We just copy that common denominator. We don't mess with anything. We're done with that part. Now what we do is we perform the operation using our numerators. So we have 3 plus 1, that's 4. Then 4 plus 2, that's 6. So we get 6/7 as our answer. Now we always want to report our answer as a fraction that is simplified or reduced to its lowest terms. Now in this case, 7 is a prime number, and 6 is 2 times 3, so there's not really anything we can do to simplify this further, so 6/7 is our answer. All right, now we're going to look at 9/2 minus 3/2 minus 11/2. So again, we have a common denominator of 2. So when we look at our answer, we'll just put a denominator of 2, and then we'll just perform the operations using the numerators. So we'd start out with 9 minus 3, that's 6. Then we'd subtract away 11. So at this point, you might already know that 6 minus 11 is -5. But again, you can convert it and say, okay, 6 minus 11 is the same thing as 6 plus -11. we use the sign from the number with the larger absolute value. So we're going to have a negative here. And then we just do 11 minus 6, and that's 5. So we get negative 5 as our answer there. So once we've written it up here, we've got a negative 5 over a 2. So that's negative 5 halves. And again, we're looking to simplify. Well, 5 is a prime number, and so is 2. So there's nothing we can really do. This is as simple as it's going to get. So our answer here is just negative 5 halves. All right, let's take a look at 4/5 plus 3/5 minus 8/5 minus 7/5. So again, we have a common denominator of 5. So when we write our answer, the denominator will be 5. Now we just go through and perform the operations with the numerators, and we work left to right. Remember your order of operations, we work left to right with addition and subtraction. So we do 4 plus 3, that's 7. Then 7 minus 8, 7 minus 8, you can think of as 7 plus negative 8. Of course, the answer would be negative. And you would do 8 minus 7, that's 1. So you get negative 1. Then we're subtracting away 7 from that. So you can think of that as negative 1 plus a negative 7. Negative plus negative is negative. 1 plus 7 is 8. So we get negative 8 there. And our answer would be negative 8/5. Now again, we always want to look to simplify. Forget about the negative. 8 is 2 times 2 times 2. 5 is a prime number, so nothing we can cancel between numerator and denominator. And our simplified answer is negative 8/5. Hello and welcome to Pre-Algebra Test Section 4 on adding and subtracting fractions. So we just want to perform the indicated operation, and we're just going to be adding and subtracting here. So we're going to start out with 2/18 plus 5/20. Now again, you already know, if you've watched all the videos so far, that if you add or subtract fractions, you have to have a common denominator. So here we have a denominator of 18, here we have a denominator of 20. So before we can actually add, we have to change each fraction into an equivalent fraction, meaning it has the same value, but with a common denominator. So in order to do that, we find the least common denominator for these two fractions. So the least common denominator, which we abbreviate LCD, is going to be equal to the least common multiple, which we abbreviate LCM, of 18 and 20. So how do we find the LCM of 18 and 20? Well, we start by factoring each number. So 18 is going to be what? 9 times 2, 9 is 3 times 3. So 3 times 3 times 2. For 20, think about that as 4 times 5. 4 is 2 times 2. So 2 times 2 times 5. So we build the LCM from the prime factorizations. Basically, every prime factor from every prime factorization is going to go in. It's just when you have something that's common to both, you're only going to put in the largest number of repeats between those prime factorizations. So for example, with the number 2, I have one factor here and then 2 factors here. So because it's common to both, I use the largest number of repeats between either prime factorization. So I'm going to go with 2 factors of 2 because that's the largest number of repeats. So 2 times 2 here. Then next I have 3 times 3. It's not common to both, so I just put 2 factors of 3 in. Then I have a 5. That's not common to both, so I just put 1 factor of 5 in. So now all I have to do is multiply, and I'll have my LCM. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Then 36 times 5 is 180. So once we've found the least common denominator, what we do is we rewrite each fraction as an equivalent fraction where 180 is its denominator. So if I look at 2 over 18, I know that if I multiply 18 by 10, I would get to 180. 18 times 1 is 18, then put a 0 at the end, you get to 180. So I'd multiply this denominator by 10. But again, to make this legal, I got to multiply the numerator by 10 as well. Remember, when we multiply by 10 over 10, we're basically multiplying by a complicated form of 1. 10 over 10 is 1. Multiply by 1, you leave the number unchanged. Now I'm going to do the same thing with 5 over 20. How do I go from 20 to 180? Well, I need to multiply by 9, right? 20 times 9, 2 times 9 is 18. Put a 0 at the end. So to make it legal, I multiply the numerator by 9 and the denominator by 9. And I'm just going to continue this down here. And let me just kind of erase this, make it a little easier for us to follow. So I'm going to put the LCD as 180, and I'm going to continue this down here. So I would multiply, 2 times 10 is 20. 18 times 10, we know that's 180. Then plus, 5 times 9 is 45. Over 20 times 9, I know that's 180. So now that I have a common denominator, my operation is relatively simple. I just use the common denominator as the denominator for my answer, and I just add the numerators. So we do 20 plus 45, and that's 65. But we're not done, because whenever we work with fractions, we always want to report our answer as a simplified fraction, or a fraction that's reduced to its lowest terms. So we would think about, what is the greatest common divisor between 65 and 180? And for 65 and 180, they're kind of big enough to where I would want to factor the numbers to make sure that I got the right answer. 65 is 13 times 5. And for 180, let's just go ahead and write this as 36 times 5. And I know 36 can be further broken down, but we can see that 13 is a prime number, and 36 is not divisible by 13, so really we can stop here, right? We can only cancel out a common factor of 5, meaning the greatest common divisor, or the greatest common factor, for these two numbers would be 5. So I'm left with my simplified result, a 13 in the numerator and a 36 in the denominator. So 13 over 36 is going to be my simplified answer. Okay, next let's look at 3 over 38 minus 2 over 133. So again, if we don't have a common denominator to start, we're looking for the least common denominator, and that's the lowest common multiple, or the least common multiple, between 38 and 133. So 38 would factor into 19 times 2. 19 is prime, and so is 2. For 133, I know we don't work with that number very often, but basically it's 19 times 7. Okay, so to build our LCM, again, everything goes in there, but when you have a factor that's common to both prime factorizations, use the largest number of repeats. So I'm going to have a 2 times a 7 times only 119. Okay, don't put both of them in there, because the largest number of repeats, in each case, we only have one factor of 19, so I'm going to put 1 when I build my LCM. So what is 2 times 7? That's 14. Then times 19, that's going to be 266. Now we'll just rewrite each fraction as an equivalent fraction, where 266 is the denominator. So we have 3 over 38. And remember, 38 is 19 times 2. So to get to 266, I just need to multiply by 7, and I'm going to do that in the numerator as well, right? So I multiply by 7 over 7 so that it's legal, right? I'm multiplying by a complicated form of 1. Then minus, I have 2 over 133, and 133 was 19 times 7. So what I need to do is multiply this by 2 over 2, right? That would give me a denominator of 266. So again, let's continue this down here. And I'm going to just kind of erase this and put 266 here. And we'll multiply. 3 times 7 is 21 over, again, a denominator of 266. Then minus 2 times 2 is 4 over a denominator of 266. So 21 minus 4 is 17. And this is over 266. So again, we always want to report our answer as simplified. We know that 17 is prime, and we know the prime factorization of 266 is 2 times 7 times 19. So we don't have a 17 in there, so there's nothing we can do to further simplify this fraction. So 17 over 266 is going to be our simplified answer. Hello and welcome to Pre-Algebra Test Section 5 on adding and subtracting fractions. So we just want to perform the indicated operation, and we just have one problem. We're going to do 5 over 12 plus 4 over 21 plus negative 6 over 24. So again, when we add or subtract fractions, we have to have a common denominator to do that. So if we start out and we don't have a common denominator, we're first going to find the least common denominator, abbreviated as LCD, and this is equal to the least common multiple, abbreviated LCM, of your denominators. So we want the least common multiple of 12, 21, and 24. So we would factor each number to start. So 12 is 4 times 3, or 2 times 2 times 3. 21 is 7 times 3. 24 is 6 times 4, or we can think of that as 2 times 2 times 3 times 2. Now when I build my LCM, I'm putting every prime factor in for the prime factorization of the LCM. The only stipulation is if I have something that's common to, in this case, at least 2 of the prime factorizations, what I'm going to do is I'm only going to put the largest number of repeats from any of the prime factorizations in there. So for example, if I look at the prime factorization of 12, I see I have 2 factors of 2. If I look at the prime factorization of 24, I see I have 3 factors of 2. So I'm going to put 3 factors of 2 in when I build my LCM. Some common mistakes would be to put 5 factors of 2 in there. You don't need that many. You would only put the largest number of repeats between the prime factorizations. So since this one has 2 factors of 2 and this one has 3 factors of 2, you go with 3 factors of 2 because that's the largest number of repeats. Next we have the number 3. 3 occurs here, here, and here. Now the most times it occurs is just once. So we're just going to put 1 factor of 3 in when we build our LCM. Again, if it's common to at least 2 of them, just use the largest number of repeats. Then lastly we have this 7. The 7 is not common to anything, it's just in the prime factorization of 21. So we would just throw that guy in there. And now we just multiply. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. 24 times 7 is going to give us 168. So now that we know that our least common denominator is 168, what we're going to do is we're going to transform each fraction into an equivalent fraction where 168 is the denominator. So the way we do this, let's say we start with 5 over 12. You would just think about, what do I need to multiply 12 by to get to 168? Well, if you look at the prime factorization for 168, and you just kind of circle, okay, this is 2 times 2 times 3. That would give me 12. So what's left in here? I'd need 7 times 2 or 14. So if I multiply 12 times 14, I'd get to 168. Now, because I do this to the denominator, I have to do it to the numerator to make it legal. 14 over 14 is 1. If I multiply by 1, the number is unchanged. Next, we're adding. We have a 4 over a 21. Again, what do I need to multiply 21 by to get to 168? So if you look at 21, it's 7 times 3. So what I'd be missing is 2 times 2 times 2, or 8. So multiply this by 8 over 8, and your denominator will be 168. Then lastly, I have a negative 6 over a 24. If you look at 24, it's basically 8 times 3. So 2 times 2 times 2 times 3. So essentially I need to multiply by 7 over 7 so that my denominator will be 168. So 5 times 14 is 70. We know that 12 times 14 is 168. Plus 4 times 8 is 32. 21 times 8, we know that's going to be 168. Plus negative 6 times 7 is negative 42. Over 24 times 7, that's 168. And now we just add. So 70 plus 32. 0 plus 2 is 2. 7 plus 3 is 10. So I'd have 102. And I'm adding to that a negative 42. So the sign's going to be positive. And we just want to subtract 102 minus 42. 2 minus 2 is 0. And basically you'd have 10 minus 4, that's 6. So you'd have a positive 60 as your numerator. And then the denominator just stays the same, right? It's the common denominator here of 168. Now we're not done because we always want to simplify our fraction. And both numbers here are even. So at minimum, they're divisible by 2. Now I happen to know that 60 is divisible by 4, right? 60 divided by 4 is 15. So let's write 60 as 5 times 3, or 15, times 2 times 2, or times 4. And this is over 168 divided by 4 is 42. And again, kind of a quick way, if you look back at your scratch paper, you can see that if you had 2 times 2 here and you kind of box that off, what would be left is 2 times 3, that's 6, times 7 is 42. So you'd basically have 2 times 2 times 2 times 3 times 7. So now you can look and see what you can cancel between numerator and denominator. You can cancel 2 factors of 2 in the numerator, with 2 factors of 2 in the denominator, basically canceling out a factor of 4. And then you can cancel out this factor of 3 from the numerator and denominator. So your greatest common divisor, or the greatest common factor between these two numbers, is 4 times 3, or 12. So if you knew that, you could divide 60 by 12 and get 5. And you could divide 168 by 12 and get 14. This works too, right? We canceled everything out and figured out that we get a 5 left in the numerator over 2 times 7, or 14 in the denominator. So we have 5/14 as our simplified answer.